Math 2 several years ago. It was in Math 2, but it was one of those things like with honors, I usually did it if I had time, but with regular, I usually did not do it, and I'm not even 100% sure if it's still in Math 2 or not. So, have you seen this before? Sine A over A equals sine B over B equals sine C over C. Seen a lot of notes. So this will be our first experience, it seems like, for most of you with law of sines. This is another thing, students usually do pretty well with law of sines. So it's kind of similar to doing regular triangle trig. It's going to be a different rule that we can use. But law of sines is really, really helpful because you don't have to have a right triangle for law of sines. So you can, this will work on any triangle. It will also work on right triangles. So that's why I said some kids forget about regular trig and start using law of sines all the time because you can. It will work for right triangles as well. So, so in this triangle here, you can see I've labeled all of the angles, the vertices of the triangle here with capital letters. And then the side across from that angle has the lowercase letter of the same letter. So like here's angle A and side A right here. Angle C is across from side C. Angle B is across from side B. So whenever we see sine A, sine B, sine C, the capital A, B, and C, those are our angles. Lowercase a, B, and C, those are our sides. Okay. For this stuff, whenever we set this up, if we have an angle, it has to be over the side across from it. Of course, we are not going to use all three of these pieces at once because we can't have an equation that's got two equal signs in it because we can't really solve that very well, right? So, so we'll only be using two of these, and I'll show you what that looks like here in a minute. Law of sines, honestly, would be really easy if there was not for one thing that we have to watch out for. So you guys would have zero trouble with it if it weren't for this thing down here at the bottom. So and let's see if you guys did this. This would have been Math 2 also, I think. Is it in 3 now? I'm not even sure. Whenever you were in Math 2 or 3, you had like angle, side, angle, angle, side, angle, side. It was proven that triangles were congruent. Side, 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 angle, angle. Different postulates to prove triangles are congruent. You guys remember doing that? Okay, Bo says at least sounds familiar, but some of you say no. So, so to back up before you think I've just written the A word here on these notes for no particular reason. So, if you had fully done congruent triangles, if you're trying to show that two triangles are the same, there's several different ways that you can show that they're the same. If they have all the same side lengths, then they have to be equal to each other. If you are congruent to each other. If you have two angles and a side that's not included, they have to be equal to each other. If you have a side, an angle, and a side, they have to be congruent to each other. But you have to watch out for the angle, side, side. So angle, side, side is like this. So let's say that I have a triangle, and I know this angle, and I know maybe this side right here and this side right here. So I've got an angle over here, and I've got two sides, and the angle's not between it. This is angle, side, side. If you have angle, side, side, you cannot prove two triangles are congruent. So if you know two sides and an angle that's not in between it, there's actually two triangles that can have those measurements. Well, actually, sometimes there are two triangles that could have those measurements. If you have the angle in between the two sides, like this, you have side, angle, side. So that angle is where those two sides meet. This is side, angle, side, and you only have one triangle then. But for angle, side, side, two triangles may be possible. So we have to be really careful, because if we are given angle side side, that's an angle that is not between the two sides. That should have a parenthesis there that ends. Two different triangles may be possible. So we have to look out for this whenever we're doing this. It's going to cause what we are going to call the ambiguous case. So it is the one thing that makes law of signs a little bit tricky, although it's not too bad. So what we're going to do when we're given a problem is we are first going to decide if we have angle side side and even need to worry about it. All right. So in this problem, I've got two angles and one side. So I've got angle, angle, side. So I do not have to worry about the ambiguous case. So here's a smiley face because I can just do law of signs. I don't have to worry about anything. So to set this up, if we're looking for side B right here, we are going to take sine of angle B, which is going to be 68, and we're going to put it over side B, which we don't know right now. And then we're going to do sine of the other angle that we know, which is 37, over the side across from it, which is 3. So it's a proportion here that we're setting up. And let me get my calculator real quick. And check your calculator to make sure it's in degree mode. If somebody reset it from yesterday, it won't be. So this is a proportion here. So if we want to solve it, the quickest way to solve a proportion in most cases is to cross multiply. So when we cross multiply, it doesn't matter which part comes first. I usually try to put the part with the variable first. So B times sine of 37 is going to equal 3 times sine of 68. You could write that the other way around. 3 sine 68 equals B sine 37. That'd be fine there. And if we're wanting to get this B right here by itself, what should we do? Good. Okay, so B is going to equal, and we'll just type this into our calculator. So we got 3 sine 68 divided by sine 37. And we're going to get 4.622. And so that would be the length of side B there. You cannot use regular trig on this triangle because it's not a right triangle. So we have to use law of signs here. Okay, questions on this one? Okay, let's try another one. Okay, so we've got triangle PQR, and they give us lowercase p, lowercase q, and capital P. So I'm going to draw myself a triangle here. Let's see, angle P is 120 degrees, so let's make it like this. This is angle P, that's 120 degrees. And then side P is across from it, that's 28. Q is going to be 22. I'm going to put that here. And R here. This is probably not really drawn to scale, probably much at all, but we got an idea of what this looks like. So once I get a picture of what this looks like, I need to ask myself, do I have angle side side? Because if I have angle side side, there's going to be one little extra thing that I have to do. So in this case, I've got an angle and two sides. And is that angle between the two sides? It is not, because if it was, it'd be over here at R, right? So I have angle side side. So watch out. There. Be careful with this. This is the only time you get to write ASS on your paper without any consequences here, because this is inappropriate, but we mean angle side side. So we're going to set it up. When you have angle side side, you set the problem up just like you did for the last problem. You don't do anything different in the setup or even the solving in the first step. So, we know that we've got 120. We have to use that because it's the only angle we know. So sine of 120 is going to go over 28. And then it tells me to find angle R. But do I know the side across from angle R? No. So what we're going to have to do is we're going to have to find this angle Q right here first. But once we find it, it'll be pretty simple to find R because all the angles add up to 180. So we can find that pretty quickly. So let's find Q first. So we'll say sine of Q over 22. Okay, so to solve it, we're going to cross multiply. This one's going to have a little bit more with it because we got sine of Q instead of just a Q. So we're going to have 28 sine Q equals 22 sine 120. Okay, and we want to get that Q by itself. What should we get rid of first? 28, we got to divide it off. So I got sine of Q equals, I think I'll go ahead and type all this stuff in the calculator. So 22 sine 120 divided by 28 is going to give us 0.680448. Keep that number in your calculator. You don't necessarily have to write it all down, but keep it in your calculator. Because we're not done. Because we still have sine of Q. How do I get rid of sine? Inverse sine. So I got to do sine inverse. And so Q is going to equal, we do sine inverse, and you can do second, the negative key to get the answer so you don't have to type that number in again. We get 42.879. Now, this is for sure, actually, this is for sure one of the answers for Q. I'm not going to put a box around it because it actually asks us for R. But sometimes when you have angle side side, there's actually two triangles that are possible. So you don't know really about, do you know anything about a unit circle? Pi over 2, pi over 6, square root of 2 over 2. If that sounds familiar, I don't think you know that. So you don't know about the unit circle yet. So it's not going to necessarily make sense why this is the case. So don't worry so much about the why because we'll eventually get to that. But whenever our calculator gives us this answer, it's giving us what we call it principal value. There are actually two answers to that. Okay, so, or actually there's infinite answers, but there's another one that's going to be of interest to us. So there's another answer the calculator's not giving you because it can only spit out one answer to you. So that other possible answer, so to check for what we call the ambiguous case, we need to do this. The first thing we're going to do is we're going to take 180 degrees minus the angle that we just found, so 42.879 degrees. And so if I do 180 minus this number, I'm going to get 137.121 degrees. What this is another possible answer for Q. So maybe it definitely could be 42.879. That's definitely an answer. It could be 137.121. We got to check, right? So then we're going to put the possible answer in the triangle and see if it will work. Okay, so Q, I know Q could be 42.879. That's definitely an answer. But I want to see if it could also be 137.121. Could that work? No. Because the angles of a triangle have to add up to 180 degrees, right? Well, if I've got, this one's already 120 and this one's 137.121, it's no longer a triangle, right? It's just like a, it's going to look like this. If you got two obtuse angles, they're not going to connect, right? So, in this case, this is not ambiguous. So, Q is our only, 42.879 is our only answer. We cannot have 37.121. The question did ask us for R instead of Q, so we would need to do 180 degrees minus the 120 degrees minus the 42.879 degrees. And so measure of angle R would be, if you ever see that M angle sign R, that means measure of angle R. You'll see that. Again, if you guys had really had geometry, I would have stressed that, but they destroyed geometry whenever they chopped it up and put it in Math 1, 2, and 3. So, you guys won't necessarily know what I'm talking about there. So, 42.879 is going to give us 17.121. So, 17.121 degrees is our answer for the measure of angle R. Okay, questions? All right, now I'm pretty sure I've got the next one is actually going to be ambiguous so that you can see what it looks like whenever you got to do one that's ambiguous. So here we're asked to solve the triangle. And to be honest, I hate solving triangles because it's like 3, possibly 6 problems rolled in one if you got the ambiguous case. To solve means to find all of the lengths of the sides and all of the angles of the triangle. So, some of those are really easy to find. Some of them are not as easy to find. It just depends on what part you're working on. So, whenever we look at this triangle right here, there's only one thing we can find to begin with. What could we find for this triangle to begin with? We need to find angle B, angle C, and side B. So I'm going to label this little lowercase b here. We need to find all of those, But what's the only one we can find right now? Angle C, right? Because we know the side across from it. So that's what we got to start with. And do we have angle side side here? We do. So since we have angle side side, we've got to check for ambiguous case. So we don't want to forget that. But we set the problem up and solve first. So to set this up, we know angle 70. So we got sine 70 over the side across from it, which is 25, equals, and we are going to have to find C here. So sine of C over the side across from it, which is 26. Okay, so just like the last problem, we're going to solve this by cross multiplying. So we'll have 25 sine C equals 26 sine 70. We can divide by 25. So sine C equals 26 sine 70 divided by 25. It's going to be 0.97728. And so on. And how do I get rid of that sign again? Inverse. So I'm going to do sine inverse of that number. And I get 77.763. This is definitely a possible answer for C. But this is angle side side. So once we find this first angle, we have to check to see if it's ambiguous or not. So there's a possibility that C could also equal 180 degrees minus this value, 77.763. And before we do that in our calculator, let me show you something that can be helpful in the calculator. If we round things during the problem, it can throw our final answer off. So, one thing I like to do you guys know how to store a number on the calculator? Okay, so this is kind of cool. That's a really long number. I don't want to write the whole thing down. And actually, like, even though it stops there, the calculator's got more decimal places saved in it. So if I can store this as a letter, then I can just use that letter instead of having to type that number over and over again. So the store key is right here above the on key. So first of all, you have to have 77.76329809 on the line before. And if you click STO, which is right there above the on key, you can store it as any letter that you would like. So if you haven't ever left messages on your calculator for everybody and know how to change it to letters, you hit the alpha and the, I'm gonna store it as C since this is angle C. So alpha, C, and enter. So what has happened now, if I type a C, the calculator knows that that is 77.7629,809. So that way I don't have to round it, it's using the whole thing. Okay, so there's a possibility that possibly, and I'm storing it right now before I subtracted, because once you move on, you can't store it as easily. So if I do 180 minus that number, see if I type in, I could do 180 minus the answer here, or I could do 180 minus C, and it gives me 102.237. Okay, so what I want to know is, could angle C also be 102.237? It could this time, right? Because 70 plus 102.237 would just be 172.237, which is less than 180 degrees. So this is a possibility for your triangle. So what has happened here is you actually have two answers for C. This is called the ambiguous case because you don't have just one answer. It's ambiguous. You don't know which one is correct. If you wanted to know which one is correct, you would have to go back. Like if this is real world stuff, like if you had taken these measurements, you'd have to go back and either measure another angle or another side to know for sure what your values would have to be there. Like if I look at this, it looks more like it's 77.763, right? Just looking, but like anytime you're taking one of my tests, certainly, because I definitely don't draw everything to scale perfectly. You won't have to take a state test for this, but on ACT or something, it'll have something that says it's not drawn to scale. It's usually drawn to scale, but you just can't assume things about it. So both of these are possible answers. Here's the bad thing about it. That means, since they told me to solve this triangle, that means there's also two answers for the measure of angle B, and there's also two answers for the length of side B. So what happens when you have ambiguous cases, if you're asked to solve the triangle, it's like you got to do the problem twice. So I kind of hate to get ambiguous case problems, but it does happen sometimes. So we're going to pretend like this actually is just 77.763 first. So if this side is 77.763, let me erase this right now and put 77.763. Then I am going to have, I know that this angle 70, this is 77.763. I could just subtract from 180 to find angle B. So if I do 180 minus 70 minus, I can just tell it C, because I've got that stored and it won't have to round any. I get 32.237. Now, I need to use this to find side B. So I'm going to store this as B. So to store, again, it's going to be that number, that STO right above your own button. And then I'm going to tell it alpha B here. So to find side B, I would have to do sine of 32.237 degrees over B equals sine. You could use either one of these. You could use 70 and 25, or you could use C and 26. I usually try to use the one that's original from the problem. So I'm going to do sine 70 over 25, so I don't have to worry about like rounding or anything there. And so we will cross multiply with B sine 70 equals 25 sine of 32.237. And to solve that, I have to divide by sine 70. And I have stored, this number right here is my B, so I can type it in like this, 25 sine of B divided by sine of 70. And it will give me that side B equals 14.191. So this is one set of possible answers here. But C might not be 77.763. C might be 102.237. So we've got to go back now and solve this again. So this might be 102.237 degrees. And I'm going to do 180 minus that C value again, just so I can get like the exact number. That 102.237 really is 102.2367019, because we did 180 minus the 77.763 for that. So I'm now going to change this and store this as C here. So it's stored as C. So B, I'd have to do 180 minus 70 minus that C value. So the other possibility for my angle here is 7.763 degrees. So that's a possibility. And I'm going to store this one as B now. So store B. And so now I got to set this up. It's basically the same thing I just did, except for that 32.237 is turned into a 7.763. So sine of 7.763 over B equals sine 70 over 25. We will cross multiply. B sine 70 equals 25 sine 7.763. Got to divide by sine 70. So 25 sine B over sine 70 is going to be our B equal 3.594. So we got that possibility also. Questions? These are fun and exciting, aren't they? Can't wait to do a bunch of ambiguous case problems, I'm sure. Let's see. Alright, I'm going to, well, yeah, we have a ton of time. I'm going to skip to example 5 here, because we don't have a ton of time. This one, we've already done one a lot like this, because you got 2 angles and a side, so you don't have to check for ambiguous case on that one. You would just do regular law of sines there. So I'm going to skip that one, because we're about to run out of time. So Aspen and Gillian look up at the chimney and find the angle of elevation to the top of the chimney to be 56 degrees. They step back 2 meters, and they find the angle of elevation from that point to be 54 degrees. How tall is the chimney? Okay. So, this is actually something super useful in, like, surveying. So, if you are surveying land for something, or if you are, like, you might need to survey a building or something. So, like, this problem, these are not exact measurements because I didn't write those down. I made this problem up because I didn't want to go down there and measure it all, but I should go actually measure it so it's even more real life. But back where you're going from the course room down to the gym, band room down to the gym, there's this really tall chimney there, and it's got a fence around it. And there's like different like pieces of equipment there. I think it's the heating and air system that's centralized there. But whenever we used to do these problems, I would have students make clinometers. You guys do it with Miss Ball, or did you make like a little thing you looked through and saw how tall things were? Yeah, measured angles. She sometimes does that because it's her favorite thing to do. It's not actually a Math 1 curriculum, but it's her favorite thing. Yeah, it's her favorite thing, so sometimes Miss Ball does that. Yeah. And so you can measure the angles of elevation, and you can figure out how tall something is that otherwise would be pretty impossible to figure out how tall it is, right? Because like the flagpole, I mean, I guess you could go figure out from the company you bought it from how tall it's supposed to be, but if you don't have that, it's going to be really hard to like run a tape measure. I guess you could run a tape measure up, but it's going to have to be a really long tape measure. It's going to be difficult to do, right? Some things are super difficult to do. So, but with the flagpole, you can generally do right triangle trig because you can measure all the way to the base of the flagpole. The problem with the chimney out there, so if we've got our chimney, and it's generally a good idea, put some smoke coming out of it, sometimes a chimney. If you draw your pictures to be kind of realistic, don't spend 20 minutes drawing a picture of a beautiful chimney. But if you actually, at least try to help yourself see, oh, this is the chimney, that sometimes is helpful to know where to label things, especially if you maybe get your triangles mixed up sometimes. So that's why I actually draw my little airplane and draw my different things here. So we've got our ground here, but our problem is around this chimney, there is a chain link fence. And unless you do, like one of my classes did one time and went and found Aileen and got her to unlock the fence for them so they could just measure all the way to the base of the chimney, you can't measure to the base of this chimney, right? So, you could measure to the edge of the fence,